piecewise linear functions, and you have 1, 2, 3 graphs here written out as linear graphs, and you've got a certain domain of values to feed into this particular function. Right, so let's go ahead and do it. When I feed 0, look, x values from 0 to 3 inclusive go into here. Well, isn't this just always a height of 3? So isn't this always going to be 3, 3, 3 when we feed it in? And so that would correspond now to a height of 3. Everything's always a height of 3, all the way from x is 0 to x equals 3. So there's the first piece. This corresponds to this. And now let's feed in 4, 5, 6 for here. Remember, we can feed in decimals, so we can feed in a 3.01. 3.01 would go into this function, and 3 would go into this piece of function here, but there would be a join for sure. Alright, so let's go ahead. Let's go 4 goes into here. 3 4s are 12, minus 6 is 6. 5 goes in here. 15 minus 6 is 9. And now 6, right? 6 goes into here. 3 6 is 18 minus 6 is 12. That makes sense. Look, it's going up by 3. Can you see it's going up by 3? Because the gradient here is 3. So this is 4, 6, 5, 9, 6, 12. Okay, so let's go to 6, 12. 4, 5, 6, 10, 11, 12. Just check some of the numbers. 4 with 6, 4 with 6, that works. 5 with 9, so automatically it should work. And finally, let's go ahead 7, 8, 9. When we put 7 in here, 2 7s are 14. 24 minus 14 is 10. Okay, substitute 8. 2 8, 16. 24 minus 16 is 8. And substitute 9 into here. 2 9s are 18. 24 minus 18 is 6. And that shouldn't surprise you. This is coming down by 2, negative 2, and there's the gradient, negative 2 here. So let's go and grab this last spot. The last point on the domain is 9 for the x and 6 for the y. So 9 for the x and 6 for the y is here. Check some of the points. 8 with 8, 8 with 8, that checks. And 7 with 10, 5, 6, 7 with 10. And there we have our piecewise linear function. You can also do the same on your TI-Nspire. So I'm going to type in 3. But now I have to tell the calculator that we're going to draw this between 0 and 3. So if we do control equals, we get this slash sign here. So this is given, that's like conditional. And we need to say 0 will match exactly the signs. That's less or equal to x, and that is less than or equal to 3. That's quite nice. I'm just going to go grab this and change the scale a little bit. Okay, that's nice. There's the first one. And now if I hit tab, I'll open up the graph menu again, and now this is 3x minus 6. The problem is if I enter it now, can you see it? It goes over the parts that we need it to. So we have to go and double click on it. We have to restrict the domain. So remember, control equals given that, and now it's between 3 and 6. 3 control equals is less than x. Control equals is less than or equal to 6. That's nice, right? I'm going to go and change my scale a little bit. So you can actually, if you can double click on these numbers, you can change it automatically like this. If that's a little bit fiddly, it can be. You go menu, window zoom, window settings. Alright, so here's my x from negative 4. I'll just go negative 1 to 10. Then my y values, I'll go also negative 1, and I'll go up to 15 here. That looks better, right? And now we've got the final piece of the function to fit in from here, and that's the 24 minus 2x. So remember, tab. The long way is menu, graph entry, and function, right? But the quick way is tab, and it opens up the most important thing for you, which is to draw a graph. And this is 24 minus 2x. And again, if we just draw that, it will draw a continuous graph, to infinity in both directions. So we need to restrict the domain given that 6 is less than x last one is less than or equal to 9. On it goes, and there you have your piecewise linear function. Piecewise because it's pieces stuck together, and linear because they're straight lines. Okay, hope that helps.